For as long as there have been fighter jets, there have been the wingman, the pilot who flies beside you, who watches your back, who covers your blind spots, and takes the risks you cannot take alone. The wingman is the reason pilots come home. And the wingman's job, flying into the most dangerous airspace in the world, drawing fire, protecting the lead, has always been the most lethal position in any air battle. For anyone who has seen the legendary movie Top Gun, the last dialogue of that movie is, "You can be my wingman anytime." Now, the significance of wingman can just be summarized in this little phrase. For the first time in history, things have changed. The wingman does not have to be human. 8 days ago, Pakistan's Air Force chief flew to Turkey, walked into a hangar, and stood in front of the machine that makes this real. A jet-powered stealth drone already in operational service, already tested in air-to-air combat, and already being negotiated for production inside Pakistan. That photograph just told the world exactly where Pakistan is going. Can a drone really shoot down a fighter jet with no human control? Is Pakistan about to leapfrog India in one domain India thought it was winning in? And is the era of the fighter pilot, the most romanticized figure in modern warfare, finally coming to an end? Today on Radar Mode, the loyal wingman, the drone that fights and flies like a fighter jet, and the deal that could change Pakistan's air power forever. My name is Qasim and you're watching Radar Mode on Pakistan Connect. This week we're going deep on one of the most consequential shifts in modern military aviation, the loyal wingman drone, and on what it means specifically for Pakistan that this technology is now at our doorstep. If you're expecting a standard drone episode, this is not that. We are going to explain exactly what a loyal wingman is, take it apart function by function, so you understand what it actually does in a fight, look at who in the world is building them, and when all of this will tie together with specific Pakistan story that broke this week. By the end of this episode, you will understand why every major air force on the planet is racing to field this particular technology, and why the photograph of Pakistan's Air Force chief in Turkey last week is not just a diplomatic snapshot. It is a declaration of intent. Let us build this up from the ground up. Before we get into this photograph, let me give you 3 numbers. 170. That is how many JF-17 Thunder fighter jets Pakistan is currently operating at this moment. The backbone of Pakistan Air Force. The second number is 1. That is how many pilots sit inside a JF-17 when it goes to war. Unless we're talking about the B variants, which we're not at the moment. And third number is 0. That is how many pilots will sit inside Pakistan's next generation of combat aircraft. Because the future of air power is not more pilots. It is no pilots. Jet-powered, AI-driven, radar-evading combat drones that fly alongside manned fighters, watching, jamming, deceiving, striking, and taking every risk that no Air Force wants its pilots to take anymore. Now, the photograph. On May 22nd, 2026, just days ago from the recording time of this episode, Air Chief Marshal Zahir Ahmed Babar Sidhu, Pakistan's most senior Air Force officer, visited Turkey on an official invitation. He met with the Turkish Defense Minister, he met with the Turkish Air Force Commander, and he met with Seljuk Bayraktar, the chairman of Bayraktar Technologies, the company behind the TB2 drone that rewrote the rules of modern warfare in Ukraine and Libya. But here is what is significant about this particular visit. During the entire trip, the air chief met with Bayraktar and only Bayraktar. No TAI, Turkey's national aerospace company that makes fighter jets, not Aselsan, which makes radar, electronics and avionics systems, not Roketsan, which makes missiles, just Bayraktar. And then he was photographed in front of the Bayraktar Kizilelma. In the world of defense procurement, that combination, the most senior officer of an Air Force visiting only one company, being photographed next to one specific aircraft, is as close to a public statement as you will get without holding a press conference. Pakistan's Air Force chief has essentially told the world that this is the platform we're interested in. This is the direction we're going. The question is, what exactly is he pointing at? And what does it matter for Pakistan, for the region, and for the future of air power? Before we talk about the Kizilelma specifically, we need to understand this concept of a loyal wingman. Because the loyal wingman idea is not just about one aircraft. It is about one fundamental restructuring of how air forces fight. And to understand this properly, we need to go back to the basics. Picture a classic air combat scenario. Two fighter aircrafts go on a mission together. The lead pilot commands the flight. He makes the tactical decisions, chooses the targets, manages the engagement. The wingman's job is to protect the lead, covering the blind spots, watching for threats from behind and all the sides, engaging secondary targets, absorbing some of the pressure that would otherwise fall entirely on the lead aircraft. Every fighter pilot in the world will tell you the same thing. Your wingman is what keeps you alive. But here's the problem. The wingman's job is also the most dangerous position in any air battle. The wingman flies into the same threats as the lead. The wingman takes the same risks. The wingman sitting in that cockpit is someone's child, someone's parent, someone's person. And when the threat environment is intense enough, sending a human wingman into it becomes a decision that carries enormous human cost. Now ask yourself, what if the wingman did not need to be human? That is the loyal wingman concept. Replace the human wingman, at least for the most dangerous tasks, with an unmanned aircraft that operates with sufficient autonomy and artificial intelligence to function as a genuine combat partner for the manned lead. The human pilot stays in command of the overall mission, making the high-level decisions, but flying alongside, controlled through a data link, is an autonomous drone that can go where the humans cannot safely go. Do what the human should not have to do, and if necessary, be lost without a human life being lost with it. That is the starting point. But the actual functions of a loyal wingman in the combat area is far richer and more complex than just replacement of a wingman. Let us go through them one by one, because this is at the very heart of why every serious air force in the world wants this technology really bad. The first and most fundamental thing a loyal wingman does is go ahead. It flies in front of the manned strike package or the manned strike formation of aircraft, sometimes dozens, sometimes over 100 kilometers ahead, penetrating defended airspace where a human pilot would be in immediate danger. As it flies forward, its sensors are active, building a real-time picture of the threat environment where the enemy radar systems are and what air defense missiles are active, where enemy aircraft are positioned, and what gaps exist in this defensive network. All of that information is transmitted back continuously to the manned aircraft flying behind. The lead pilot, instead of flying into the unknown, receives a detailed live briefing on exactly what is ahead before he arrives. He can plan his approach, he can choose his attack corridor, and decide whether to engage or to withdraw, all based on information gathered by a drone that no human being was inside. The practical effect of this is enormous. It extends the detection envelope of the entire formation dramatically. The manned pilot can effectively see and understand the battle space from a drone's position, not just his own. And he can make decisions accordingly with far more information than any single aircraft operating alone could ever generate. Secondly, the most dangerous mission that you can possibly fly in any aerial warfare, the SEED mission, the suppression of enemy air defenses, means going after the radar systems, surface-to-air missile batteries, and command nodes that make up the adversary's air defense network. These systems are specifically designed to detect, track, and destroy incoming enemy aircraft. Flying a SEAD mission or a suppression of enemy air defenses mission means deliberately entering the airspace those systems are designed to control, activating them so they reveal themselves, and then attacking them before they can kill you. This is the military aviation equivalent of throwing a stone into a hornet's nest. Historically, SEAD missions required highly specialized, extremely expensive aircraft and the most experienced of the pilots in the Air Force. Because the casualty rate in poorly executed SEAD operations is devastating. A loyal wingman, an autonomous drone, changes this calculation completely. You send the drone forward, the radar emissions or its electronic warfare systems deliberately generating signals cause enemy air defense radars to switch on and attempt to track it. The moment those radars activate, they reveal their position. Anti-radiation missiles fired from the drone or from manned aircraft safely behind it follow the radar signals back to its source and destroy it. The drone absorbed the danger. The enemy air defense network is degraded. The manned strike package can now fly through airspace it could not safely have entered before, and no pilots are dead. The US Air Force has already described this concept explicitly. Loyal wingman drones push past ahead of the manned strike package, activate electronic warfare suites to map and jam enemy radar networks, fire anti-radiation missiles at radar emitters that activate against them, and with the air defense picture degraded, manned fighters operating safely behind coordinate the strike using sensor data relayed back from the forward nodes. Thirdly, modern air defense systems depend on radar and radio communications. They need to detect targets with radar, track them, communicate targeting data to the missile batteries, receive guidance updates, and coordinate across all the network. All of those signals are electromagnetic, which means all of them are susceptible to jamming. They can be jammed, disrupted, spoofed, or exploited. A loyal wingman drone equipped for electronic warfare can emit powerful jamming signals that blind enemy radar over a specific area, preventing it from tracking the manned aircraft behind the drone. It can intercept enemy communications, identifying command frequencies and disrupting coordination between air defense nodes. It can spoof enemy radar, generating a false return signal that makes the radar think an aircraft is somewhere it is not, drawing fire in the wrong direction. It can flood enemy detection systems with so much noise that they cannot distinguish real targets from ghost signals. While all of this is happening, the manned aircraft behind the drone flies through at a temporarily blinded air defense environment. The drone is essentially creating what military planners call an electromagnetic corridor, a path of degraded enemy sensors through which the strike package can penetrate without being detected, tracked, or engaged. Fourthly, every air defense system has a finite number of missiles. Every radar operator has a finite amount of attention. Every command node has a finite bandwidth for processing threats. Loyal wingman drones exploit all three of these limits simultaneously. By flying ahead of the manned aircraft and presenting radar signatures that look like real threats, sometimes deliberately mimicking the radar cross-section of the fighter jets, loyal wingmen force enemy air defense operators to expend expensive interceptor missiles against drone targets. A surface-to-air missile that costs between $2 to $5 million is fired at a drone that costs maybe $1 to $2 million, or even less. The exchange ratio favors the attacker. More importantly, each missile fired at a drone is a missile not available to fire at the manned aircraft coming behind it. This is the decoy function, and it is devastatingly effective because modern air defense systems struggle to distinguish reliably between a loyal wingman drone and a manned aircraft, especially when both are flying in coordinated formation and the drone is designed with a radar profile that resembles a manned aircraft. The result is a strike package that arrives over its target having systematically depleted and confused the defenses that were supposed to stop it. The human pilots never entered the lethal envelope of the full air defense network. The drones did that for them. Fifthly, a loyal wingman is not just a support platform. It is a weapons carrier, and in some configurations, a primary strike asset in its own right. Consider the numbers. A manned aircraft can typically carry 4 to 8 air-to-air missiles in a stealth configuration, or more in beast mode or non-stealth external loadouts. Now imagine that fighter accompanied by 4 loyal wingman drones, each carrying 4 to 8 additional missiles. The total firepower available to the manned pilot has quintupled, but only one aircraft in that formation has a human being inside it. The pilot commands their engagement. The drones execute his orders, firing their weapons on his targeting commands, engaging threats he designates, or engaging automatically or autonomously with predetermined rules of engagement. China's FH-97A Loyal Wingman is significantly designed as what analysts call a missile truck, carrying up to 8 air-to-air munitions that the commanding J-20S can unleash in a massive simultaneous barrage against enemy aircraft in a single volley. A single J-20S commanding a formation of FH-97As can effectively flood an adversary's defensive radar and missile systems with far more simultaneous threats that any human pilot could generate alone. For strike missions against ground targets, Loyal Wingmen carry precision-guided bombs, cruise missiles, and anti-ship weapons. They can be directed to attack specific targets while the manned aircraft stands off at a safe distance, controlling the engagement through that data link without ever entering the most dangerous airspace. Sixthly, number 6. Here's one of the most underappreciated functions of a loyal wingman, and arguably one that has the greatest operational impact. A manned fighter aircraft has a limited sensor suite. It has its own radar, its own electronic warfare receivers, its own electro-optical targeting system. These sensors point primarily where the aircraft is pointing forward. The pilot has limited ability to simultaneously maintain awareness of what is happening behind him, to his sides, below him, and at a long range multiple directions, all at once. A loyal wingman formation solves this problem by distributing sensors across multiple platforms. One drone is forward, scanning the threat environments ahead. Another is to the left flank, monitoring that sector. Another is above, with a top-down radar picture. All of these platforms are simultaneously feeding their sensor data through encrypted data links into the manned aircraft's cockpit display and into a shared network that includes ground-based radar, AWACS aircraft, satellite data, and other aircraft of the same formation. The result is what military planners call sensor fusion. I love this word. Sensor fusion. The combination of data from multiple sources into a single, coherent, continuously updated picture of the battle space. The manned pilot is no longer seeing the battle through a keyhole, through the limited view of his own sensors in one direction. He is seeing it through 20 eyes, simultaneously, from 20 different positions fused into one single display. One analysis found that the US Air Force reports 78% faster decision making when wingman drone systems are integrated, because the pilot is not spending cognitive bandwidth searching for information. The information is arriving already processed and prioritized from distributed sensor networks around him. This is also described as battle space awareness, something that we have touched many times in the past. And it is the characteristic of the modern warfare that is most often decisive. The side that sees the most accurately, and most quickly wins the first exchange. In a short intensity conflict of the kind Pakistan experienced in 2025, the first exchange can effectively determine the entire outcome. And finally, the final function of a loyal wingman is arguably the most strategically significant, and it operates at the level of economics rather than tactics. A fifth-generation manned aircraft, an F-35 or a J-20, costs between $100 and $200 million per aircraft. Training the pilot to fly it takes a decade and costs tens of millions more. Replacing either the aircraft or the pilot in wartime is slow, it's expensive, and strategically very painful. Militaries that have spent decades building these capabilities are deeply reluctant to risk them in the most dangerous missions. A loyal wingman drone, however, in current configurations, costs between $10 and $40 million. It requires no pilot, If it is lost in combat, the program manager orders another off the production line. There is no funeral, there is no national grief, there is no pilot training pipeline that needs years to rebuild. A drone is described in military planning as attritable, meaning it can be used in high-risk missions because its loss, while costly, is acceptable and replaceable. This changes the entire risk calculus of air operations. Missions that were previously too dangerous to execute, deep penetration of heavily defended airspace, extended suppression of enemy air defenses operations in the heart of an integrated defense network, close escort of high-value strike packages through maximum threat environments. Now, these missions become executable when the assets taking those risks are not manned aircraft, but are manless drones. The cumulative effect of all of these 7 functions is not incremental improvement. It is doctrinal evolution. An air force with loyal wingmen does not fight the battle versions of the same air war its predecessors fought. It fights a categorically different kind of air war, one in which the number of effective aircraft in the sky is decoupled from the number of pilots available, in which manned aircraft operate from safer positions with better information and more weapons than any single platform could carry, and in which the enemy's air defense network is systematically blinded, depleted, and confused before the decisive engagement even begins. A loyal wingman is not a niche experiment. It's being pursued by many militaries across the world. It is the central axis of air power development across every major and several military powers simultaneously. The global financial market for the loyal wingman drone was valued at about $2.41 billion in 2025 and is projected to grow to $5.87 billion by 2034. This is not a niche research program. It is an industry. And every serious military power has concluded that the question is not whether to acquire this technology, but how quickly they can get it. Into this global race steps Turkey, and through Turkey, potentially Pakistan. The Bayraktar Kizilelma, which means red apple in Turkish, is Turkey's first jet-powered, stealth-capable, unmanned combat aerial vehicle developed entirely by Bayraktar Technologies using private funding with no government money. It began conceptualization development in 2013. It was first revealed publicly in 2021 and made its maiden flight in December 2022. That is a remarkably fast developmental cycle for an aircraft of this complexity. Now let's talk about what it actually is, because the word drone does not begin to cover it. Most drones you have heard of, the TB2, the Wing Long, Pakistan's Sharper series, are what are called MALE drones, MALE, medium altitude, long endurance platforms. They fly relatively slowly at moderate altitudes and are primarily effective against targets that cannot shoot back. They are powerful. They changed warfare, but put them in an airspace defended by modern radar and missiles, and they become very expensive wreckage very quickly. The Kizilelma is an entirely different animal. It is powered by a turbofan jet engine, the same class of engine that powers fighter aircraft. It cruises at Mach 0.6, roughly 740 kilometers an hour, and can push to Mach 0.9, just under the speed of sound. It has a combat radius of 500 nautical miles, about 1,000 kilometers. It operates at altitudes up to 45,000 feet. This is where most of the fourth generation fighters fly at. It weighs 8,500 kgs at maximum takeoff and carries up to 1,500 kilograms of weapons. Now these could be laser-guided bombs, air-to-surface missiles, and critically and most importantly, BVR missiles. These are beyond visual range air-to-air missiles. It has a stealth-optimized airframe with a low radar cross-section. It can take off from short runways, and it runs on an onboard AI system that enables fully autonomous taxi, takeoff, cruise, landing, and mixed mission execution, including target identification, threat assessment, and engagement with minimal or zero human intervention. In plain terms, the Kizilelma is a fighter jet without a pilot. It goes where fighter jets go. It does what fighter jets do, and nobody's child is sitting inside it. In November 2025, the Kizilelma did something that had never been done before in the history of unmanned aviation. It shot down a jet-powered aerial target using a beyond visual range air-to-air missile guided by its own internal AESA radar, with no human pilot controlling the engagement. Listen to that again. A drone independently detected a jet-powered target, classified into a threat, tracked it, made the engagement decision, fired the missile, destroyed the target, all by itself. This is not incremental progress, this is watershed. Because until that moment, the debate about whether unmanned aircraft could function as genuine air combat assets, not just strike platforms against static ground targets, but actual air-to-air fighters capable of engaging other aircraft, it was theoretical. The Kizilelma answered that debate in November 2025 with a missile and a falling target drone over the Black Sea coast. In December 2025, two Kizilelma prototypes conducted autonomous close formation flying, maintaining precise separation from each other, using onboard AI without human input. That is the other half of the loyal wingman capability. Not just fighting alone, but fighting in coordinated formations, with other aircraft, sharing information, executing coordinated maneuvers, and responding dynamically to changes in the tactical situation on ground. The platform entered Turkish Air Force service beginning the first quarter of 2026. It is no longer a prototype or a concept. It is a production aircraft in active service with demonstrated air-to-air combat capability. Turkey became only the third country in the world, after the United States and China, to field a jet-powered loyal wingman unmanned aerial vehicle in operational service. And Pakistan's Air Force chief was photographed standing in front of one 8 days ago. The air chief's visit to Bayraktar did not come from nowhere. The Pakistan-Bayraktar relationship has been building quietly and methodically for several years. And understanding that history is essential to understanding where the Kizilelma story goes next. Pakistan first acquired Bayraktar's TB2 drone in 2021 to 2022, along with the heavier twin-engine Akinci MALE drone. These gave Pakistan its first serious Turkish origin armed drone capability, alongside existing Chinese wing long platforms. But what happened next is what makes the Bayraktar relationship categorically different from a standard procurement. On the back of those acquisitions, Bayraktar embedded a team at Pakistan's National Aerospace Science and Technology Parks, the NASTP, and co-developed two entirely original products with Pakistani entities. The first was the Qasim V3, a miniature turbojet-powered air-launched cruise missile with a 150 kilometers range and AI-based guidance, designed from scratch around PAF requirements. The second was the EHA loitering munition series. Neither product existed in Bayraktar's catalog because Pakistan was the initiator. Both of these products were specifically for Pakistan's needs. That is not a vendor-customer relationship. That is a co-development. And it tells you something important about Bayraktar's model. The company comes inside, understands the requirements, and creates something new altogether. Turkey's defense exports surged 30% in the first 11 months of 2025, and Bayraktar is at the center of that growth. Pakistan is not just one customer, it is a strategic development partner. Subsequently, Bayraktar established Bayraktar Technologies Pakistan as a formal in-country subsidiary, which analysts assess as focused on engineering and manufacturing rather than simply sales. In December 2025, Bloomberg reported that Turkey and Pakistan were in advanced discussions to establish a dedicated drone assembly plant in Pakistan. By the time of the air chief's visit in May 2026, those discussions had clearly advanced significantly, and Turkey is now formally Pakistan's second largest supplier after China in arms and ammunition, a position it did not hold even 3 years ago. Now we have to be precise about what exactly Pakistan negotiating, because the answer is more sophisticated than simply buying some drones. Reports indicate that an initial batch of 6 to 8 Kizilelma A subsonic variants is under discussion, with options for supersonic upgrades in the future tranches. But the hardware is almost secondary to the framework being built around it. Technology transfer and domestic co-production is the central demand. Pakistani engineers at NASTP would be involved in producing subsequent units, with progressive localization of airframes, avionics, and mission systems. This mirrors the PISAT satellite deal from our last episode. Pakistan is not just buying capability, Pakistan is buying the industrial knowledge to build its own capability. Every technology transfer deal Pakistan signs is one more step towards genuine defense industrial sovereignty. The integration plan centers on manned-unmanned learning with the GF-17 Thunder fleet. The Kizilelma has already been tested flying in formation with the F-16, demonstrating that it can function as a genuine wingman to a fourth-generation fighter, sharing data, coordinating targeting, and responding to the lead pilot's commands through a high-bandwidth data link. Adapting that to the GF-17, Pakistan's most numerous frontline fighter with over 170 airframes in service, would give every GF-17 squadron a force-multiplying unmanned partner, capable of performing all 7 functions we discussed earlier in the most dangerous parts of the flight. A Pakistani-Turkish aircraft designed from scratch for Pakistan's specific operational environment, geography, threat systems, and data links. To understand why the Kizilelma matters so much, beyond its individual capabilities, you need to understand Project Azam, the Pakistan Air Force's long-term plan to develop the next-generation air power, including a 5th-generation fighter aircraft. Project Azam is quite ambitious. Pakistan and Turkey are formally partnered on a joint 5th-generation fighter program, a merged development track combining PAF requirements with Turkey's Khan program, with manufacturing planned in both countries. Pakistan, China, and Turkey are working on a loyal wingman UCAV program under this broader framework. But building a 5th-generation fighter is enormously complex. It takes decades and requires aerospace industrial capabilities that Pakistan is still building. The Kizilelma sits precisely in the gap between what Pakistan has today and where it wants to eventually arrive. Defense analysts have described the Kizilelma acquisition pathway as a bridge for Project Azam. The drone is complex enough to build genuine aerospace engineering capabilities inside Pakistan. It requires mastery of stealth design, advanced aerodynamics, autonomous systems, and high-performance jet propulsion. All of these competencies feed directly into the longer 5th-generation fighter development. You cannot build a stealthy manned fighter if you have never built a stealthy unmanned one. The Kizilelma is, among other things, Pakistan's industrial training program for harder challenges that follow. The May 2025 operational lesson is embedded in this thinking too. During the conflict with India, Pakistan airfields were targeted, raising the question of how you would sustain air operations when runways are cratered or saturated with incoming missiles. A drone launched by rocket-assisted takeoff from a dispersed, unpredictable location, a forest clearing, a motorway, a mountain pass, is far harder to preempt than an aircraft requiring fixed, known or unknown runways. The Kizilelma operational flexibility, including potential carrier-based operations from Pakistan Navy's vessels, extends the PAF in reach in exactly the scenarios where fixed infrastructure becomes a liability. Now, you can't complete a radar mode episode without the regional picture, and here is the picture. It's quite stark. India is acutely aware of what Turkey and Pakistan are building together. It is pursuing the Boeing MQ-28 Ghost Bat through deepening US-India defense ties. It has its own CATS warrior programs, real, funded, and developing, but still a demonstrator and not yet a flying combat aircraft. India's Air Force is simultaneously absorbing a massive 114 aircraft Rafale order, managing the delayed Tejas Mark 1A program, and the development of its loyal wingman architecture, all competing for the same budget engineering bandwidth at the same time. The Kizilelma-Pakistan combination accelerates pressure on every one of those Indian programs. If Pakistan deploys a jet-powered stealth drone capable of BVR or Beyond Visual Range Combat by 2028. India's CATS Warrior or the CATS Warrior, which has not yet flown, suddenly looks dangerously slow. South Asia is, as one defense analyst put it, becoming the next operational laboratory for AI-driven aerial warfare. Both sides are buying these systems, both sides are watching how they perform, and every step in this partnership is being factored directly into the Indian and Pakistani procurement decisions. This is not a stable equilibrium, it's a race. And Pakistan, for perhaps the first time in the drone domain, is in a position ahead of where India expects to be. Because that is what radar mode always delivers, here's the honest assessment. What Pakistan gets is significant. A jet-powered stealth platform capable of both air-to-air and air-to-surface combat. A loyal wingman for the GF-17 fleet that multiplies combat power without multiplying pilot risk. Technology transfer and co-production capability feeding directly into Project Azam. A partnership with Turkey that has proven it co-develops rather than just sells. And military options in the high-threat scenarios that simply did not exist for the PAF a couple of years ago. What Pakistan still needs to address is also clear. The Kizilelma currently uses a Ukrainian-sourced turbofan engine. Ukraine's own war has demonstrated precisely how geopolitical disruption can sever supply chains. Turkey is developing an indigenous engine replacement, but it is not yet available. For any serious long-term co-production arrangement, the engine question needs to be solved through a secure supply agreement, a propulsion technology transfer, or integration of an alternative power plant. Solvable, but not yet solved. The integration of the Kizilelma autonomous systems with Pakistan's satellite-based kill chain, data links, and command networks, which we covered in the detail in our last episode, will also require significant engineering work. Platforms not simply plug into each other. Making Kizilelma a genuine node in Pakistan's network military architecture will take time and resources. And there is the question of numbers. 6 to 8 aircraft is a statement of intent, but not a combat capability. The PAF has over 170 JF-17s. A handful of Kizilelmas provides a demonstration and a development pathway. Actual operational impact requires scale, and the co-production arrangement is the mechanism at which this scale becomes achievable at a cost Pakistan's defense budget can actually sustain. One photograph, one 4-star general, one aircraft with no seat, no cockpit, and no human being inside it, and an entire strategic decision made visible in a single moment. The loyal wingman is not a future idea. It is the present reality of air power for any serious military in the world. The US is spending billions on it. China has operationalized it with the J-20S and the FH-97A. Australia, Britain, France, Russia, and India are all racing together. Turkey arrived there with Kizilelma. And now Pakistan's Air Force chief has stood in front of it, been photographed, and left everyone watching to draw their own conclusion. The Bayraktar Kizilelma is the leading edge of a fundamental change in how air wars will be fought. The question is not whether this technology will define the next generation of air combat. It already does. The question is who has it, in what numbers, integrated into what architecture, and how quickly they can scale it up. Pakistan has decided clearly at the highest level that it intends to be among the countries who answer that question with action rather than aspiration. The red apple, it turns out, does not fall far from the tree. And Pakistan's Air Force has decided it wants to plant a complete orchard. That is all from Radar Mode this week on Pakistan Connect. My name is Qasim, and I genuinely hope this episode changed how you see the future of air power and Pakistan's place in it. If you learned something new, hit that like button, subscribe to Pakistan Connect, and if you haven't already, share this with someone who cares about where Pakistan is heading. And leave a comment. I would love to know what you think. Is the Kizilelma the right direction for the PAF? What questions does this raise for you? I read every single comment and I'll be sure to reply. This is Qasim signing off. Stay sharp, stay informed, and I'll see you again on Radar Mode next week.